So let's just set the record straight on copper, since there seems to be a bit of confusion in this space about copper and copper toxicity. Did you know that you can actually have too much copper in your body and still be copper deficient? Let me get a bit technical for a minute, so hang in there with me. Copper comes from food traditionally, but nowadays we get copper from birth control pills, the copper IUD, copper pipes. Copper also gets passed from mom to baby. Once copper enters the system, it's absorbed largely in the small intestine and it is bound to copper uptake proteins. The main one is called CTR1 or copper transporter 1. This brings the copper into the intestinal enterocytes. Once it's inside the enterocytes, copper binds to chaperone proteins like CCS, ATOX1 to avoid free radical damage. From the intestinal enterocytes, copper then enters the portal blood and binds to albumin and transcuprion for transport into the liver. The liver then stores the copper, incorporates copper into proteins, and distributes copper to the rest of the body. Then, while it's still in the liver, copper is loaded onto ceruloplasmin, which is a copper-carrying protein. Ceruloplasmin carries up to 95% of plasma copper, and when copper is bound tightly to the ceruloplasmin, it is bioavailable and safe to be utilized in the body. However, if we have low ceruloplasmin, then we have bio-unavailable copper. Ceruloplasmin is what delivers the copper to energy enzymes like cytochrome C oxidase in the mitochondria, and this is involved in ATP production, and also to antioxidant enzymes like superoxide dismutase, and lastly to iron metabolism enzymes, so iron can bind to transferrin. But if copper is unbound because we have low ceruloplasmin, then it is toxic as a free ion and can build up in the tissues. In addition, excess copper is excreted mainly via the bile, so if a person has a lot of liver congestion, which many people with chronic illness do, then they probably aren't eliminating it very well either. So only very tiny amounts of copper are eliminated through the urine. If the system really fails, like in the case of mutations like Wilson's disease or Menkes disease, then that is a real problem. But most of us don't carry these mutations and we still have copper dysregulation issues, mainly because we have low ceruloplasmin, meaning copper gets stored in the tissues, but it is not bioavailable to be utilized. So we end up with copper toxicity and deficiency at the same time. This can lead to common chronic illness symptoms that we see today, like fatigue, brain fog, neurologic symptoms, connective tissue issues, eczema, all kinds of chronic skin conditions, mast cell activation, allergies, kind of any symptom you can think of, copper can be related to that symptom. So now keep in mind that zinc and copper are also antagonistic. So given many of the deficiencies of zinc in our diets, it's no wonder that copper builds up over time. Also, with everyone taking high-dose zinc supplementation for, immune support, this can cause a copper deficiency and lead to symptoms like fatigue, anemia, or connective tissue issues. How we kind of view, in terms of HTMA, remember that HTMAs measure stored copper in the hair tissue, not circulating copper. And this is a very important distinction and something that I think people don't fully understand. So when ceruloplasmin is low, then copper is not properly bound and it becomes bio-unavailable. Free copper gets stored in the tissues, things like the liver, the brain, the joints, or the hair follicle. The symptoms of this are endless, like I talked about, anything from anxiety to eczema to acne to fatigue to hormonal imbalances like estrogen dominance. And so when you see a high copper on an HTMA, it doesn't necessarily mean that there's true copper toxicity in the bloodstream. It just means that there's poor utilization of this copper. So ceruloplasmin is mainly made in the liver. Again, that's the copper protein that we need in order to bind copper in the liver. It's mainly made in the liver, but there's also small amounts that we produce in the brain, the lungs, the immune cells. And in order to make ceruloplasmin, we need copper, we need proteins, we need vitamin A, we need vitamin C, and we need iron. So we're likely seeing reduced ceruloplasmin because of nutrient deficiencies, protein deficiencies. Many people don't get proper or sufficient dietary protein. And then also adrenal burnout and stress, which really reduces the liver's ability to load the copper properly. Since adrenal stress or burnout is basically widespread, there's not a single person that I see in my clinic that doesn't have some level of adrenal burnout. This leads to weakened liver function, which lowers ceruloplasmin production over time. And it kind of unfortunately becomes this terrible vicious cycle where stress weakens the adrenals, less ceruloplasmin is made, copper is not bound, it builds in the tissues, and then the free copper is extremely toxic, so it increases oxidative stress, and then this stress burden worsens, which further worsens adrenal burnout. And so it becomes this horrible catch-22 cycle. And so this is also why on HTMAs, when people do mineral balancing long-term, they start to dump copper. When their glands begin to heal, their body is finally able to mobilize the stored copper from tissues, and this helps break the cycle over time. This is also why on mineral balancing, we support the adrenals so much and the thyroid as well as the liver, because all of those things need to be well supported in order to increase ceruloplasmin production in the liver. So to all the people saying that copper toxicity doesn't exist and that HTMAs can't show copper toxicity, they're actually dead wrong and haven't studied mineral balance in the body or HTMA science in general. They're likely focusing on blood copper levels, which would indicate more acute copper toxicity, not chronic toxicity over time. So in my opinion, HTMA is the best way to identify dysfunction in the mineral matrix as a whole, instead of just kind of having a narrow focus on one mineral. We're looking at the entire mineral matrix and how one affects the other. And so over time, this is going to lead to a more reduced burden on the body. And then the glands are able to catch up. You're able to get out of adrenal burnout. You're able to produce ceruloplasmin again. And then you're able to release that the excess copper. And then actually get out of copper deficiency as well, because you're actually able to now utilize that copper in the cells.